Okay, so that quiz question, what was it? It was 5x plus 6 and 5x minus 10. Okay, so this was the quiz. And we're supposed to FOIL it out, right? Like we did a bunch of those yesterday. And so that means the first one goes to both, right? The first goes to both. So 5x times 5x. What happens when letter type things multiply? Out front numbers multiply, powers add, right? So the invisible 1 powers on the x's add. So 5 times 5 is 25. And the invisible 1 powers add. 25x to the second power. Now, 5x goes to minus 10. Minus 50x. He's done now. He's went to both, right? He's visited both of the other two. Now the plus 6 goes to both. Plus 30x minus 60. Is that good? And then these middle two make what? Minus 20x? Because now this is adding, subtracting. You just do the numbers in the front. Don't mess with the powers, huh? Yes. You change gears like that. So there's the answer. That was B, huh? Is that good? Mm-hmm. We all good with that? All right. On to 2.6 we go. All right, so there's 2.6. And we have 6 to the 7th over 6 to the 3rd. All right, we're looking for the rule there. Does anybody know the rule when you have like, well, here, let me give you a hint. I bet you can figure it out. Remember what we learned? What is like x squared times x to the 3rd?
x5.
X to the 5, because you add the powers, huh? So when you're multiplying same bases, you actually add the powers, don't you? Right? What would be like 2 to the 2nd times 2 to the 3rd? 2 to the 5th. Remember, same rule. We can't change the new rule, Jose. You got to stay with the same rule there. Right? Same rule. Add them up, right?
That's 2.
Oh, yeah, sorry. That's a funny looking 2. Yeah. Add those powers, right? Same rule. Notice we do not multiply the bases. It's not 4. It's not 2 times 2 is 4. Even though we think, well, yeah, but 2 times 2 is 4. Yeah, but that's just not what it is. Right? Because what is 2 squared? 2 2's. What is 2 cubed? 3 2's. What do we got there? 5 2's, not 5 4's. So it's true. You leave the base unchanged and add the powers. That is the true rule, right? When you're multiplying. So when you're multiplying same bases, add powers. Let me write that. So when you, I don't know where to write it. So when you multiply same bases, you add the powers. Okay, so that's multiplying, timesing same bases. You don't actually multiply the bases. You just add the powers. So I bet you can figure it out. So what about, now that we have this one, what about if you divide same bases? Yeah, because here I'm dividing. I'm not multiplying. It's not 6 to the 7th times 6. If it was, yeah, what would 6 to the 7th times 6 to the 3rd be? Yeah, we would add the 7 and the 3 to be 10, huh? If we were multiplying them. But we're dividing them, so what do you think dividing is? Yeah, totally, huh? Subtract them. 7 minus 3 is 4. We're done. Right? Divide same bases, subtract powers.
If the power it's bigger than
Oh, we'll get to that. Yeah, well, I can say it even now. Yeah, wherever the bigger one is, that's where the answer is. I'm glad you're thinking about that, Jose. You're right. Yeah, so this one, the bigger one was on the top. So there's the answer, no problem. But if that bigger one had been on the bottom, then let me go over here. The bigger one, yeah, it's 1 over. Exactly. You guys are on it. You guys don't need me up here. You know these rules. Excellent. Yeah, if the bigger one had been on the bottom, it'd be 1 over 6 to the 4th because the bigger one was on the bottom. So wherever the bigger power is, that's where the answer ends up. Does that make sense on that? So on this one, now this one you might say, did that one end up on the top, 6 to the 4th? Because the bigger power was up here on the top. So is this on the top? How so? You're right. It's really over 1. We just don't show 1s on the bottom, do we? 1s on the top, we must leave. Why? Who made that rule up? What's my answer going to be every time we say y? Who's on the throne? Who's on the throne of math? Mr. Heron? No, not Mr. Heron. Truth, right? It's the truth. Because one half of a pi is not the same as 2 pies. Right? So a 1 in the top is not the same as a 1 in the bottom. Those are different, aren't they? So if we get an answer like with a 1 in the top, we can't just get rid of that and go, oh, that's just the same as 2. No, it's not. 2 pies is not the same as a half pi. But when you get an answer 2 over 1, yeah, that is the same as 2 because 1 goes into 2 times. It's just what's true. So, long story short, 1s in the top must stay, 1s in the bottom we ignore. Right? So yeah, so this is really, anytime you have something alone, like 6 to the 4th alone, it's really over 1. It's really in the top. We just don't show it, because 1's in the bottom we don't show. Yeah, so this one followed that rule. Bigger power in the top, answer in the top, so to speak. On that. Question? Makisha?
But you said, say that one more time, wherever the bigger power is.
Yeah, wherever, and we'll do several of them, but it's good to get it even now. Wherever the bigger power is, that's where the answer ends up. So, yeah, let's do another one where it's actually on the bottom, and I'll write that out at that point. All right, so 8 to the negative 2 power. Isn't that strange? What in the world does that mean? You know these rules, huh, Lena? Yeah. Let me first remind you, what is 8 to the regular 2? 8 times 8, 64. Yeah, it means the 2 means repeat twice, multiplied. We know that, right? That's what the little numbers in the upper right-hand corner started out, right? We all agreed. And that was just math making a rule. That wasn't logical. They just said, hey, we put numbers in the upper right-hand corner, they're going to mean that thing multiplied by itself that many times. So anyway, it's a repeat symbol, isn't it? It means repeat twice, multiplied. Great, we know that. So then what is negative 2? Well, it means repeat negative 2 times.
That'll be positive?
So what's that? What if somebody said, how many times did you do that? I did it negative 2 times. What does that even mean?
You did it twice?
Yeah, what does that mean? Well, Alina, what does that mean?
8 plus
8 to the positive 2. Yes, that's what it means. Isn't that bizarre? Where'd the fraction come from? Let me write that a little more neatly. That's what it means. Negative powers make things jump to the other side of the fraction, to the bottom. And then the power becomes positive.
So that's
What? That's the answer. Or you can make it 1 over 64 if you want. 8 squared, 64.
I don't get it.
Yeah, it's bizarre, isn't it?
Is it, are you considering the invisible 1 under the 8 negative, the negative 2? Is that where you're getting that 1 from?
No.
It's not an invisible.
A negative power just makes it jump to the bottom. No.
just negative.
Just negative, yeah. So let me just write that out for you. Negative powers make it jump to, I'll just say the bottom. Then the power becomes positive after the jump. In fact, let me do this, guys. Let me be more clear. Instead of the bottom, it jumps to the other side. Now, what do I mean? Well, I mean if it started on the bottom as a negative power, it would actually jump to the top and then become positive.
So we would hit positive or no?
So let me give you a couple of examples. That's probably the best thing. So, for example, if they had given me, well, here, I'll let you guys write that down, and then I'll do some examples to clarify. And let me erase it and write it more neatly. Okay, so what I'm saying is 8 to the negative 2 power. Here's a little helpful memory device. I always think of it as like somebody that's unhappy at their job, right? Somebody that's at a kind of a negative job. She's 19 now. My 19-year-old girl, my oldest girl, is working at, she got a job at a nice steakhouse. What's it called? Yosemite Ranch place up there as a hostess. So she's making some big bucks to pay for college. but she doesn't like it there. They're kind of mean there. Anyways, kind of a, she had another job that they were much nicer people, so I don't mean to tell on that place, but it's all right. They've earned what they've got. They're just not friendly to each other. The employees, the managers, it's just, she's been there 6 months, and she's like, I think I'm gonna look for another job. I think, you should, honey. She just comes home, and they just all are rough with each other. So anyway, not a fun place to work, although she makes a lot of money, but I guess that's why people stay there. But negative, and the food is really good. My wife and I go there every now and then, but I guess the employees aren't so happy. Now I know the inside story. Anyway, so she's unhappy. My 19-year-old girl, Emma girl, is unhappy at her job. So that's what a negative power is like. They're negative about their job. It's not a fun place to work for her. They're going to jump to a new job. That's when my daughter's out throwing her application all over town. To jump to a new job. Negative power, it's going to jump. So that's how you want to think about it. Negative powers are unhappy. They're negative. They're unhappy where they're at. They're going to jump. After they make the jump, then they're happy. Then they're positive. So I'm trying to help you. Now, if it had started on the bottom, it would go to the top. So what if they gave me a problem like 1 over 8 to the minus 2? You look at it and go, okay, he's unhappy. Negative power, unhappy. He's going to jump to the top, and then he's happy. Then it becomes, now you can put this over 1, but we don't leave 1s in the bottom, right? We never show those, so we would not really bother. We just leave it like that.
So we would actually put a positive, like a positive exponent?
It becomes positive after the jump. Becomes happy.
Put the exponent, like flip it?
Oh, are you saying like you don't need to show that plus?
Yeah.
Right, exactly, you're right. Steve, right? Steven. Yeah, you're totally right, Steven. Yeah, you don't need to, it means +2 even if you don't show the plus. You're right on the money, exactly. So it's wherever it is. So negative powers, wherever they're at, they're unhappy where they're at, they're going to jump to the other side and then become positive after the jump.
But where does the 1 come from? That's what I'm not understanding.
Yeah, well the 1, let me mention this. If I, it's a good question. What if I take like 2/6, for example? How do you reduce that fraction?
To the minimum.
Well, yeah, divide by 2, right? Divide top and bottom by 2. So if you divide by 2, what do you get? What's the top? 2 divided by 2? 1. 6 divided by 2? See how a 1 popped up all of a sudden? Do you see when you let me go back and do it this way. When you reduce it, because some people just reduce like this. They go 2 goes into 6 3 times, like that, right? And suddenly there's a 1 on the top. Does that make sense? So whenever, my point in that is, look at the top. What happened on the top? The 2 canceled. So there's nothing on the top. Yeah, but there's really a 1. So my answer to that question, it's a good question, is whenever the top of a fraction vanishes, it always leaves a 1. Because we can't just go blank over 3. I mean, what would that even mean? I had blank thirds of the pie. How much pie is that? Right? So 1/3 of the pie. So whenever the top vanishes, there's always a 1. That's not something new. That's what we've always done with fractions when the top vanishes. Well, that's what happened here. This jumped to the bottom. There was nothing on the top, so that put a 1. Questions?
So we're not even working out the actual...
Oh, you could. Yeah, I'm sorry. So you would say that's 1/64th? Yeah. Sometimes they do that. Is that what you mean? 8 times 8 on the bottom?
What are they going to want as the answer in there? Is it going to be the 1 over 8 plus 2, or is it going to be the 164, the part?
Okay, so let me answer by saying, first off, it doesn't matter at all on the test. Because on the test, it's multiple choice. And they won't put both these. They'll just put one of them, and so you grab whichever one they put. So on a test, which is really where all the points are in this class, almost all the points are on the test, it doesn't matter. On the homework, they change their mind back and forth. How do you know which one they want? It says do not simplify. So they want that. But don't sweat it. You know, you know how you can always tell if you're not sure? Click the help show me an example button. Right? And it shows you the format they want the answers. Remember how I said that? So whenever you guys know what I'm talking about? So c to the minus 7. So negative powers. What's it going to do? It's unhappy at its job. It's like, I don't like this job. They pay me a lot of money, but they're mean and evil. That's how my daughter feels. And it's going to jump to the bottom, and then the power becomes positive after the jump. There's nothing on the top, so we put a 1. Just like that. Isn't that weird, by the way? You got it, right? Sounds like you guys have all got it.
Yeah.
But can we just stop for a second and say, that's just weird, isn't it? Doesn't it feel like they're just making this up as they go along?
Yes.
Would you believe me if I told you that has to be logically? And in a few minutes, I'll show you, and I think you'll all agree that it had to be that way. There was no other choice. I'll show you in a minute. Let's keep moving. Let's get comfortable. All right, so
We wouldn't just make it a positive?
yeah, so negative powers, we're always going to let them jump because they're unhappy where they're at. They're unhappy. So there's a negative power. It's unhappy where it's at. So what's it going to do? It's on the bottom. Where's it going to jump? To the top. And after the jump, it'll become positive or just regular. You know, you don't need to show that plus sign, just regular. Now, what's left on the bottom? The 1, but we don't show 1s on the bottom. It's just like that. Just n squared. Make sense? Negative powers jump to the other side, then become positive.
Now, if you put the 1 under it, it's just flipping it.
It's just flipping it. It is just flipping it. You're totally right. That's maybe I should have said that from the beginning. It's just flipping it.
Yeah.
Yeah. It's just flipping it. But the weird thing is we just don't show 1s on the bottom. So it kind of looks a little mysterious. But yeah, you're right. It's just flipping it, and we don't show 1s on the bottom.
So it would be just be P, the second power?
If it was a P, is that what yours is a P?
Oh, okay.
All right. What are mean again? They're called exponents, and what do they mean? There's a repeat symbol, right? Like 7, whoop, come on, there we go. 7 to the 3rd, for example, means 7 times 7 times 7. Let's remember where this all came from, right? We're doing weird things with these powers now. So let's remember where it all came from. Put a little 3 up there, it means, you know, multiply that 3 times, whatever that answer is, right? It's a repeat symbol. So what does it mean to repeat it 0 times?
Nothing, right?
Yeah, is it nothing?
It stays the same.
It's 1?
Stays the same, I would say.
Stays the same, just say 7 to the 0. We have a lot of options here.
Or just 7.
Or just 7?
But it's not a 1, so it can't be 6.49. Would it be like a negative? Would it go negative?
You know enough information right now to know the answer. Using logic. Without me telling you anything. Let me prove it to you. Here we go. Remember, let's what we call derive it. What is 7 to the 3rd over here? Let me make it 4 even. Yeah. Watch. I'll lead you guys down the logical path, and every one of you will agree on which of those answers it really is. I bet you. I bet you. What is 7 to the 5 over 7 to the 2, for example? What rule have we just learned about that?
7, 5 minus 2.
So 7 to the 3rd, right? Good, because you subtract the powers, right? Okay. So what? What does that have to do with this? Well, I'll show you. How about what's 7 to the 4 over 7 to the 2? 7 to the 2, just subtract the powers. Same rule, right? What's 7 to the 3 over 7 to the 2?
7.
Yeah, 7 to the 1 or 7. Totally. Good. They're just same thing. I'm just subtracting the powers, right? Right? Math is just logic. Follow the yellow brick road. Just follow the pattern. Now, what's the next one? Right, I'm just following the same pattern. What's 7 to the 2 over 7 to the 2? Follow the pattern. Oh. Remember, it's 7 to the what? 0, because you subtract powers, right? Right? See the pattern here, right? You just 5 minus 2 is 3, 4 minus 2 is 2, 3 minus 2 is 1, 2 minus 2 is 0. Same pattern. It's always 7 to the something, whatever the power subtract, right? So whatever 7 to the 0 is, it's this. Which is 1. Because it's the same thing over itself. Right? Isn't the same thing? Isn't 49 over 49? So what does 7 to the 0 have to equal?
1.
See? They're not making this up. They're following logic. It's got to be. That's strange, isn't it? But it's true. Isn't it? That's what I enjoy about math. I don't know if you like that. I like not making it up, and I like truth, logically, carefully followed. That's true. right? Just subtract, if you're going to follow the same old rule we've been following all along, subtract the powers, then 7 to the 0 is the same thing over itself, is 1. So, that's nice. Anything, let me write it this way for you. Anything to the 0 power equals 1. It's just 1. Anything to the 0 power is 1. So, what is this 6.49 to the 0 power? That's the real question they gave me. 6.49 to the 0 power. What's that? 1. What's 7,516,216 to the 0 power? 1. You're hoping for a lot of these on the test, right?
So if this is if there's a bracket with a 0 power, that whole bracket
Yeah.
is just 1.
Mm-hmm.
Okay.
That's right. Everybody seeing that? They're asking us. Okay, so 7z to the 0. All right, let me give you a second to try that one.
That will be 7.
Let me make it into 2 questions.
Times 7?
Well, let's do 2 different questions.
That will be 1 too.
Seven.
Yeah, 7.
It'd be 7 and that would be 1.
No, both of them are 7.
Right.
Huh?
Okay, so 2 rules we got to be really clear on. 0 power on anything. What does a 0 power on anything do? 1. We're good with that rule, right? Second rule is my soccer rule, right? My youngest daughter plays soccer, and the coach is always telling her what to do. When the coach tells her to, if she doesn't juggle enough, she has to do push-ups. My little girl, I think she weighs 50 pounds. It must be easy to do push-ups when you just weigh 50 pounds. She's a little feather. But the coach makes her do push-ups when she doesn't get enough juggles practice during the week. So when the coach tells Abigail to do push-ups, I don't hit no push-ups. I'm just watching, right? I'm just the spectator. So we got to be really clear. That's what I mean by my soccer rule. Are you on the field? And so you're going to listen to the power coach. Or are you not on the field? And so you're not listening to the coach. You're just a spectator. So is this 7 on the field? Or is he just watching? I'm just sitting in my lounge chair or my folding chair just watching the game. That 7's just watching. Is this 7 on the field? Yeah, he better listen to the coach. Right? So, what is this coach? The coach is a 0 power. What does the coach say to do? Anything I have power over, make it 1. Right? Anything that 0 power has power over, he's going to make it 1. So, this 0 power goes, poof, you're a 1. But not the 7. He doesn't have power over the 7. He's like, you're not talking to me. I'm not on the field. I'm just watching. Right? So this is just 7. But this one, he's talking to all of that, isn't he? And the coach says, you're all 1. Right? See the difference? So the answer in this one's 7, the answer in that one's 1. See that? It's just going to be clear who the coach has power over. Anybody on the field. Anybody in the parentheses, right? And what does the 0 power do? Makes it 1. Whomever he has power over. All these rules coming together?
So,
That making sense?
You're saying if it's parentheses 7z 0, it's going to be 1. If
Yep.
it doesn't have the parentheses, it's just going to be 7.
Right. Do you see the reason why? More.
I do see what you're saying.
Yeah, because the whole thing, the coach has power over the whole thing, so he makes the whole thing 1. Whereas here he just affects the z. He's not talking to the 7 on that. So that's real. So with powers, always be clear who the coach is talking to. Right? Only the ones on the field. Discussed. Okay, so 8x to the 0 power. So who is the coach talking to? The whole thing. And what does a 0 power coach do to anybody he talks to? Drop and give me 1. Just 1. That good? Like that? Just 1. Talk more about negative powers. Now, what did negative power coach do to anybody it's talking to? Negative powers, they're unhappy where they're at, they're going to jump to the other side. Now, here's what we got to be clear at. Does the 8 and the x both jump down to the bottom? Or does just the x? How you know is you ask, who is the negative 2 power on? Is he on both of them? Yeah, if it was like this, then he would be on both of them, and they would both jump down, huh? But it's not. He's just on the x. So the 8 stays on the top, and only the x goes to the bottom, and then becomes positive. You don't have to show positive. After, come on, give me the eraser. There we go. After the jump. So there's our answer, whichever one that is. Oh, it's A, huh? Does that make sense there? So you just always got to be clear, who is the power on?
If you work this out long way, it would be 8 times 1 over x squared.
Yeah, that's true as well. You're right, Alex. That's right. That's another way to say the same thing. You're right. Good there? That making sense? Yeah, so Alex, what you were saying is right. It's 8 times 1 over x squared like that. And then that 8 just goes to the top because it's 8 over 1. So 8 times 1 is 8. And 1 times x squared is just x squared. Another way to say the same thing. Right? All these math rules coming together for you? It's a lot of different rules, but they all agree with each other. So that's why if you know them, they kind of fit. They're back and forth. Okay, so 5x to the minus 2. Now, who is that power on? Who's the coach talking to? Everybody. Everybody's on the field. The 5 and the x. So give that a try. Negative powers, they're unhappy where they're at. They're going to jump to the other side, right?
And they will stay in parentheses in front, right?
Well,
Oh,
you could do it that way, like you're saying like this. Make that positive 2. That's true. That is true, but that's not the forms they're giving. They're not giving me that form. So that's true. That's okay, but we have to know the language well enough to know which of those it's the same as. Because what Jose is saying is right. That is another way to say the right thing. That is right. But this is the same as which one of these other ones?
A.
Yeah, it's the same as A. See that? Because that 2 is just on the 5 and on the x. It's on both. That's what the parentheses mean, huh? It's on both. So it's the same as A. Good. That's how the test will be, because multiple choice, right? So if you do this, then you just look over and go, oh, yeah, I see it. It's the same as A, and just grab A. Don't grab that none of the above unless you really are sure on that none of the above. That good? All right. Okay, so on this one, now we're going to start mixing them in where we got one of them negative. 5 to the negative 4 times 5 to the 6th. Okay, so when we're multiplying a couple of those like that, what have we learned about negative powers? What do negative powers always do? That first. I would first do the negative power thing. What do negative powers always do? They jump. They're unhappy where they're at, right? Other ones are happy. So the 5 to the minus 4, just him, he's going down. The 5 to the 6 is happy where he's at. He likes his job. He's got a positive power. He's got a positive boss. 5 to the 6th over 5 to the 4th. Like that. Is that good? Now we can do one more step. So far so good, though, right? Negative power jumps to the bottom, becomes positive. Now what can we do from here? We can subtract those powers, right? And the answer ends up where the bigger one is on the top, 5 squared. And sometimes they want you to make that 25. Sometimes they just want you to leave it. This one you can see by the blue writing. Type in exponential notation. No, leave the exponent. They just want you to leave it that way. Instead of making it 25. Won't be a problem on the test. Test will be multiple choice. They'll just have it one way. Is that good? Everybody see those steps that happened? So negative power jumps down, becomes positive after the jump, and then powers subtract. Good? Okay, so 9 to the 5th times 9 to the minus 14. All right.
Do the same.
Yeah, negative powers jump to the bottom, right? So let that negative power jump to the bottom, exactly. So this negative power jumps to the bottom and becomes positive. Good so far? Now, what do we do from here? Subtract powers, right? Remember, whenever you're dividing bases with powers, you got to subtract powers. Now, where's the bigger power? So where's the answer going to end up? On the bottom, right? So subtract. I'll subtract now. 14 minus 5, 9? And what do you put on the top when there's nothing left on the top?
1.
Always a 1. 1 over 9 to the 9th. So I did 14 minus 5 is 9. So the bases of 9 stay, and the power subtraction is also 9.
Why did the 9 power minus 14 ended up at the bottom of the fraction and not on top of it, just like the previous one?
Because the bigger one was on the bottom. On the last one, the bigger one was on the top. So wherever the bigger one is, if the bigger power's on the top, the answer ends up regular, because that's really over 1. That's really the top.
I see.
See, the bigger one, 6 is bigger than 4, the bigger's on the top. That was the last one. This one, the bigger's on the bottom. 14's on the bottom, the bigger's on the bottom, so the answer ends up on the bottom. So wherever the bigger one is, that's where the answer ends up. If the bigger one's on the bottom, the answer ends up on the bottom.
I get that part, but what I'm getting confused of, in the previous one,
Uh-huh.
see you got minus 4
Uh-huh.
and 6.
Right.
So the first part went under the fraction, right? Under the,
That's because it's negative power. Uh-huh.
But then the next one, it should be the opposite.
When you say the next one, you mean the next problem?
Yeah,
Or
the next problem.
Here, we didn't have any, yeah, no, same thing. This negative power went down. Same thing. Makes sense. On that, we good on that? That making sense? All right, so. All right, so we got c to the minus 6 times c to the minus 4. All right, so what are we going to do with those guys? Are those guys happy or unhappy? They're unhappy. They're unhappy. They're going to jump to the bottom. And then after they jump, they become positive, don't they? They're both negative. Last two problems, we only had one of them negative, the other was positive. This one, they're both negative, they're both unhappy, they're both jumping to the bottom. What's left on the top? Just a 1, okay. So far, so good. We have one more step. Now, what do we do with these guys? Yeah, well, now what do we do? Let me make sure we're all good to this point, right? So, because negative powers jump to the bottom and then they become happy, then they're positive. Now, if these guys are side by side, these guys are side by side now, right? Let me back up to the last problem. If they're vertical, they're divided and they're vertical, then you subtract the powers, right? And wherever the bigger one is, that's where the answer ends up. You subtract the powers when they're vertical. But on this one, they're not vertical, they're side by side. So what do we do when they're side by side? Add them. Exactly. We good with that difference? That'd be c to the 10th, and we're done. So side by side they add, huh? Vertical they subtract.
You could individually put them
You could. It's another way to say the same thing. You're right, Alex. You like that separate thing. Yeah, but you're totally right.
I don't know, it just made more sense to me like that.
Yeah, you're totally right. Good on that?
So they're horizontal add.
Yeah, if they're side by side horizontal, add them. If they're vertical, subtract them. Exactly right. That is right. Good there. Questions? All right. So x squared times x to the minus 4.
I don't have an app for this website.
I think there is.
Oh, there is?
Yeah, you can do it on your phone. Yeah.
No, I know.
Yeah.
I don't have an app for it.
Oh, is there not an app? Okay. Just go on the internet, but not an app. Oh, okay. I guess no is the answer. Yes. Okay, negative powers. What's that negative power going to do? Yep, he's unhappy. He's unhappy. And after he jumps, he becomes positive, becomes happy. Like that. X2 over x to the 4th. And now what do we do?
1 over x.
Yeah, when they're vertical, we subtract powers, right? We're going to subtract. Subtract 4 minus 2 is 2, right? When they're side by side, you add them, but if they're vertical, you subtract them. So it's going to be x to the 2, right? But where's it going to end up? Where's the bigger power? On the bottom. Well, what's on the top? 1. There we go. Making sense?
So that's kind of like the shortcut way, right? Because what you're really saying is you would have x to the second power over 1 times 1.
1 over x to the 4th? Yeah, you're totally right. You're totally right. And then you would subtract these guys. You can do it that way. Just subtract them and same answer in the end. You're right. You're just wanting to do the Alex method. Julio and Alex, they think alike. Let's keep them separate. I'm just always putting them together.
Mine always just makes an extra step that I have to do. But
As long as it's right in the end, it's all good.
I'm doing this math course, I need to know I'm doing it right.
Yep. That teacher was telling you the truth. All right. Try that one. Negative powers. You know the story. Hey, are both of those unhappy?
No.
Only one of them's unhappy. Only one of them's a negative power. So the bottom one's going to stay put, isn't it? But the top one's unhappy. So they're going to both end up on the bottom, aren't they? See what's happening there? Because the one on the top says, I'm unhappy, I'm jumping to the bottom. The other one that's already on the bottom is like, I'm good here. I got a positive 10 power, I'm happy. Right?
So in that sense, it's like it's dividing it by itself. Both numerator and denominator are divided by itself, right?
They're both divided. Whoop, paused it now. And what's left on, there's nothing on the top, what does that mean? 1. Good so far?
How come that didn't go,
6, 10 go up?
no, how come it wasn't 1 over 67 to the negative 16, I mean, 67 to the 16 over, like a fraction on top of the fraction?
Oh, how come it's not this? Like that? It is. That's another way to say the same thing.
Really?
Yep. Mm-hmm. That's a much uglier way, huh? That's a worse way.
Because I was thinking that too.
Yeah, okay, so let me explain. If you guys are interested, good. You guys are pushing me on all these rules, good. I like summer. Normally I do these rules and everybody they look like they're kind of catatonic. I don't know, and they just kind of take them in. All right, so we got it. I like that you guys say, what about this, what about this? Good. Yeah, let me explain. But I don't want to over-explain and confuse everybody. So this is good, and then we have one more step. Yeah, let me finish up, and then I'll go back and explain the other way. So how do we finish from here? So I don't want to confuse everybody with
add.
Yeah, they're side by side adds powers, right? So 67 to the 26, and we're done. So that's right, that's the easy way to do it, definitely do it that way. But let me answer that question, that good question, because some of you guys are thinking, well, look, negative powers, Mr. Chair, that means 1 over. True. And the bottom one just stays put. True. That's another way, not as easy of a way, to say, but it's still true. And let me show you how this will lead to the same result. Because what are you going to do with this now? Well, there's a couple ways you can go. This is probably the easiest. This is really over 1, right? Okay, so then this really means 1 over 6, 7, 16 divided by. Because when you're over, it means divided by, doesn't it? And then you flip the 1 on the right. And right? Yep. Yeah, remember invert and multiply that we did the other day? Yeah, exactly. And then you see we're going to end up in the same place. So it's a lot harder. It's true. Yeah. Isn't that great? Don't you enjoy for just a minute, though? No matter the beautiful, consistent truth of math. As long as you follow the rules truly, you will get there. That's kind of nice, isn't it? That's what I always enjoyed about math. As long as I'm logical, it's going to get there, right? It's going to arrive. I hope that's not a headset, because that's pretty loud. All right, we good? All right. So m to the minus 2 over m to the 5. So who's unhappy? Are they both unhappy?
No.
Just the one on the top's unhappy. So just the one on the top is jumping down. He's unhappy. His job, he's jumping to the bottom. But the m to the 5th is saying, I'm happy. And there's a 1 on the top because there's nothing left on the top. Like that. Everybody see that? Why the one on the top jumped down but the bottom one stayed put? They're side by side now. What do they do when they're side by side? There it is.
So what if, what if that M5, that it was a negative?
Yeah, good question. Good question, Kyle. What if they were both negative? What would that mean? They're both unhappy. They're both going to jump. No, the whole fraction is going to flip in this case. So this guy's going to come up because he's unhappy. This guy's going to go down because he's unhappy. And they become positive after the jump, right? They're happy in the new job. It'd be like that at first. Then we'd have one more step. But everybody, that's a good question. Everybody see the difference? So if they're both negative, they both jump. In other words, the whole fraction flips.
And if only the bottom one's negative, then they both go on top?
Right. If only the bottom was negative, then only he's jumping, so they'll both be on top. That's right. And then what would we do to finish this one? When we do those powers, then we'd subtract m to the 3rd, huh?
So when you jump, it doesn't necessarily mean that you go to the bottom.
Yeah.
If you jump.
It just means jump to the other side. Yeah, you can go bottom to top or top to bottom. It just means you're jumping to a new place.
So you're saying that if the m is a positive at the bottom,
Uh-huh.
why didn't we jump to the top?
Positive powers are never jumping anywhere. They're happy.
Oh, okay.
They're positive at their job.
No matter what, if it's negative, it's moving.
Yes. All negative powers are jumping. All positive powers are staying put, wherever they are.
Okay.
Yeah. So let me help so that it's not. There's really no different rules for top or bottom.
Okay.
It's all the same. If you're a negative power anywhere, you're unhappy. You're going to jump to the other side. If you're negative on the top, you're going to the bottom. If you're negative on the bottom, you're going to the top. You're going to the other side if you're negative. If you're positive, you're happy wherever you are, top, bottom, whatever. You're staying put. On that. That good?
Yes.
So yeah, so negative powers jump. So all negative powers jump to the other side. All positive powers stay put wherever they're at. Okay, so t to the 2nd over t to the minus 5. So are they both jumping? Is only one of them jumping?
Just one.
Just one of them's unhappy. So that negative power jumps to the top. He's the unhappy one, right? negative power. And then he becomes positive after the jump. That good, Joel?
And whenever you get them side by side, you add them.
Yes, and now these guys are side by side. They're not vertical. They're side by side, so they're going to add. Exactly right.
How you know to put them side by side?
Because they this guy doesn't go anywhere because he's positive,
So he's saying, okay.
so he's staying. Yeah. Whereas the one on the bottom, he's negative, so he jumped up to join the one on the top. Yeah, so positive powers stay put. Negative powers jump.
And because he's on top, he doesn't need the one, right?
Right, yeah, that's right. Because all this is on the top. We don't do the one thing. I mean, you can put the one down here if you want, but we don't really show ones on the bottom. We only show ones in the top. Making sense? Negative powers jump. They're unhappy where they're at. That's how my daughter's feeling about her job. She asked for her friend's graduation is this Saturday, her best friend's graduation party, and she asked for it off from work like a month ago, and they just ignore it. And my daughter calls all week, finally calls the head manager. She's asked everybody to sub for her, and she's like, you said that if we asked in event, he's like, yeah, no, sorry, yeah, Memorial Day weekend, everybody, no, And my daughter's pretty nice. I mean, she's not perfect, but she's pretty nice. And she got off the phone and she's like, I think I want a new job. And I'm like, yeah, you should work, honey. You'll get fired if you don't work, but go to work. You're gonna miss your friend's graduation party, but they don't care about you at all. They're just like, whatever, we don't care what you ask for off. We're just making money here at this place. So anyway, so she's jumping to a new job. That's her plan anyway. So negative powers jump. Negative powers jump to the other side. Negative.
We turn into one.
You're making up some new rules back there, Stephen. No. All right, so they're both negative. So what's going to happen when they're both unhappy?
They're both
Switch.
Yeah, so the whole fraction's flipping, isn't it?
Yeah.
Because they're both jumping. They're both unhappy where they're at. So they're both jumping.
Is it because it's a division why they're flipping versus when they're next to each other, why we're making it into a division?
Well, say that one more time?
Okay, when they're next to each other, we're making it into a division because it's a negative, if it's a negative, right?
Right, so yeah, so if it was like m to the 3, m to the minus 9, for example.
We're making it into division because they're next to each other.
Well, okay, but how about if I gave you m to the 3, m to the 9? Those are next to each other, and we wouldn't make that one into division, would we?
No, but they're positive.
Right, so it's not because, so the answer then, it's when one of them's negative that it jumps.
Yeah.
Okay, so think this way with me. Let me see if I can help. I hear your question. The main thing to be clear on, the main rule driving all the others is negative powers jump, wherever they're at. So yeah, so this right here, this guy's negative, so he's gonna jump, whereas this guy's staying. He's like, I'm not going down there, I'm positive, right? So that's why it becomes a fraction, because he wants to jump. And this one doesn't, because nobody wants to jump. So am I answering your question?
No.
So what's your question again?
I'm just wondering why it's like, okay, when they're next to each other, we make it into a fraction.
Not always,
Not always.
right? Not here.
When it's when it's a negative number though.
Okay, true.
So because this is already a fraction, is that why we're just flipping and putting it side by side?
No, so the answer to that is what I'm saying about the negative powers. So the answer to all those questions is it just depends on how they set it up with negative powers or not. Let me give you for instance. So if they gave me m to the 9 over m to the minus 3 to begin with, who's unhappy here? So Rachel's question is good. Everybody tracking with it? I'm sure Rachel's not alone in that. So only this guy's unhappy, huh? So everybody tracking with that? Only this guy's unhappy. So only he would go up. They would end up side by side actually.
Yeah.
Does that make sense? Whereas this one, they're both negative, so it's going to flip because they're both jumping. So this one won't end up being a fraction. This will end up being, because this guy only will jump, and the m to the 9 stays put, it'll end up side by side. Whereas this one, they both jump, so it ends up a fraction. See the difference? So it's just all about who jumps. So no other rule really drives anything other than who jumps. Is that making sense? That's the answer to all the questions is who jumps. As far as whether it becomes a fraction or becomes side by side or becomes whatever, it becomes whatever it needs to become based on who jumps. Does that make sense? Let the jumping. So don't think in advance. Wait a minute, is this one of those that becomes a fraction? Is this one of those? Don't even think that. Just think who's jumping.
That was more of my question.
Yeah, yeah. Don't think about because there's no real nice easy rule for that. Just think who's jumping, who's unhappy, who doesn't like their job, they're jumping,
Yeah,
and then whatever it becomes, it becomes.
it was the whole, that's why I was saying, division to side by side was where.
Yeah. No, don't. Yeah, those rules won't work. Yeah, but it's just who's jumping. So this would end up being 1 over m to the 6th when they subtract, right? Vertical, they subtract. So it's all about who's jumping.
And the nine's bigger, so it has to go to the bottom.
Yes, the power in the bottom is bigger,
I'm gonna forget that rule.
so it goes to the bottom. You're not going to forget that rule, are you? Whatever the bigger one is. Joel.
Whenever you see the negative number, that means division on the exponent.
It does.
So I just want to be clear, so you see next to each other like that, you're dividing it.
It's really true. It's going to jump to the bottom and be dividing. Yep, that's right.
So if it were m to the 9th over m to the 3rd, just reversed what
M
it
to
is,
the 9th over m to the 3rd. Yeah, what if it was like that?
then it would be,
Is anybody, so again, ask the question, anybody unhappy at their job? That's always the first question. Let that be the first thing that drives all the others. Anybody unhappy?
No.
No, they're all staying put. So nobody would jump, right? And then what would we do from there? They're vertical, so
so
we
you
would
just
subtract.
subtract.
Yeah.
But then they'd end up, the answer would end up on the top, right?
Beautiful,
Because-
excellent.
okay.
Because the bigger one's on the top. Perfect. Whereas this one, the bigger one was on the bottom, so the answer ended up at the bottom of a 1.
Right, okay.
Yeah.
If I forgot to put the 1 on top, is it wrong?
If you just say the answer is m to the 6th?
Yeah.
Yeah, that's 1, because that means over 1. If you don't write anything, it means in the top. Why? Because it's really over a 1, and we never show the ones in the bottom.
Should be m to the 6th.
What's that?
It would be m to the 6th.
Right, which is different than 1 over m to the 6th.
Also,
So that's not right. You can't write it that way. Yeah, so 1s in the top must be shown. Right, and that's from the pi thing that I said a minute ago, right? If I said, I had a half a pi, oh, just put the 2, the 1 doesn't matter. That's not true. Real life, right? A half a pi is the same as 2 pies? No. So 1s in the top are essential. They must be shown. Math Excel will mark you wrong. So 1s in the top must be shown. Must be shown. Because that makes a difference, right?
It only goes on the bottom if the,
We never show 1s on the bottom. Oh, thing jumps to the bottom?
yeah. Like, it's only on the bottom, M6 is on the bottom because of the denominator for the M.
Yeah, because the power is bigger on the bottom. Does that make sense? Power is bigger on the bottom. Yeah. Good. A lot of rules here, aren't there?
Yes.
All right. 20 to the 7th to the 3rd. 20 to the 7th to the 3rd. All right, so what's the deal with that one?
multiply that.
Yeah, good. You guys remember the rule? Remember from yesterday? What do powers outside parentheses do? Multiply powers inside. Yeah, that 3 is going to go times 7, 21. And we're done. So that's the rule from yesterday. Nothing about these negative powers and jumping and all that. Just powers outside parentheses multiply powers inside parentheses. Good? Yeah, that's it on that one. Okay. So what's the rule there? What do powers outside parentheses do?
Multiply,
Yeah, so do that first. So that would be 8 times 10, negative 80. Good so far. We're not done though, but that good for the first step. Same thing we did. You know, powers outside parentheses multiply powers inside. So that was the outside inside thing. Now, it's unhappy. He doesn't like this job like my daughter. I'm getting out of this job. They're not friendly here. So negative powers, what do?
Go to the other side.
It's going to jump to the bottom. And then they're happy after the jump. Leaves a 1 on the top. There we go.
I would have looked at that before and said, I can't solve that.
Ah.
Before these used to scare me.
Oh, okay. Oh, gotcha. Yeah.
For real, it's a number.
Just looks
Big
fancy.
an equation and.
Yeah,
And
right.
I'm like, yeah, I got a trinomial times a trinomial, I got this.
No problem. Yeah, it's good. 4 hours a day helps, huh?
Yes.
It's like cramming for an exam.
It is. It's good. I know my pass rates are always higher in summer because I think it's just helpful. You just have it, and then I hand you a test. You're like, I got it. I just did it for 20 hours. Yeah, I got it. What is more consistent? Yeah. Whereas normal semester, I'll see everybody an hour a day, 1 hour. Then they'll go off and do their other less important things, and then come back for my math class. They're irrelevant subjects. No. All right. So there we go. 1 over 1680. I love history myself, actually. I like history more than math. Does that seem weird? I'm a math teacher. But if I had to, I used to think history was so boring in high school. Oh, it was boring. They used to, in 1633. But then I got to junior college. I had Mr. Maglieri. I went to junior college up in Sacramento. Anyway, Mr. Maglieri, still remember his name. He brought history alive. It was people and events. And it was like, wow, history's interesting. I was just too far down the math science road to change my mind at that point. But anyway. History is very, very interesting stuff.
You would have thought.
Maybe. Who knows? All right. So there we go. Is that good? All right. So x to the 7 to the minus 2. Okay. Let's give that one a try. So powers outside parentheses, powers inside parentheses. Okay. So what do powers outside parentheses and inside parentheses do? Multiply. Good so far? Positive times negative is just negative. We know that. Now, negative powers, unhappy at his job. He's jumping. Power becomes positive. We're done. Is that good? This rule is all fitting together? All right. Okay. W to the minus 3 to the minus 2. Try that one. So same kind of thing. Powers outside parentheses, powers inside parentheses. So powers outside multiply powers inside, positive 6, right? Because 2 negatives multiply to be positive. Now, is that guy unhappy in his job?
He's already happy.
He's already happy. He's not going to jump anywhere. Happy, happy, happy. He's going to stay right there. And we're done. Make sense on that? Good. Good, good. Here at the end, there's the curveball. See what you can do. It's a shocker all of a sudden. It's actually the same rules. It's a shocker.
Can you write it out?
Oh, yeah, want me to make it a little bigger?
Variable in this variable in the exponent.
Yeah, exactly. It's the same thing, but they're throwing letters up there. It's a curveball. My junior high boy just transitioned to junior high baseball, and suddenly the pitchers can throw curves now. And so it's just funny to watch my son try to bat. He's been a pretty good hitter up to now with fastballs, but so he'll stand in there and they throw that curveball, and he's just like stepping out, and it's like strike. It's like, oh, that thing's moving. It's kind of funny to. First time you see a curveball, it's shocking. So this is a curveball for you here. Follow the rule there. What's the rule on that? So, so to help you with the rule, what would you do if you had like x to the 7th over x to the 2? When they're vertical, what do you do with the powers? Subtract them. Do the same thing here. I would write a single x, top power minus bottom power. Isn't that the rule we've always followed?
Yes.
Right? So let's do the same thing here. A single x, top power, 2w plus 7, minus the bottom power. Now, I got to put parentheses around the bottom power. Otherwise, I'm not going to subtract the whole bottom power. If you just write minus, if you just write it without parentheses like that, you're not really subtracting the whole bottom. You're only subtracting the w part, the front part. You got to put parentheses to subtract the whole denominator. Is that making sense there? And so then what is that? Well, that's 2w. Here, let me keep with the color scheme. X to the 2w plus 7. And then the minus distributes minus w plus 4. Everybody good there? And then what's that? Am I going too quick?
I got lost a long time ago.
Question?
Okay, so you know that negative is gonna jump over, right? Is that negative?
Yeah, the negative's going to distribute, right. Jump over,
Okay.
sure. Hit them
Now,
both, right.
once it jumps over, it's gonna become a positive. Is that 2 on the top gonna stay where it's at?
The 2w plus 7?
Yeah,
So-
once it becomes a positive, since that jumped over.
Oh, okay, no, so I'm not jumping anything.
Oh, okay. That's
Is
what I
that
wanted to
negative
know.
4
Okay.
times W?
The negative 4 is just.
No, I didn't jump anything. I just, remember the rule I showed you in the beginning? I said, what do you do if you have, like that, vertical. If you have x's, what do you do with these powers when they're vertical? Subtract them. That's not jumping anybody. That's just top power, subtract, bottom power. No jumping, right? Isn't that the rule we've always followed?
The
So
four's
it's
the
minus
minus
4?
Yeah, before that.
Oh, I see. Yeah, okay. Yeah, you guys are looking at that minus 4 and you're thinking he's unhappy.
Oh, yeah, that's.
Isn't he?
Okay. The problem with that thinking is it's not just, if it was just x to the minus 4 down there, yes, that would be right thinking. But it's not just x to the minus 4. The power isn't just minus 4, it's w minus 4. Okay, so what? That's still negative. No.
It's not a negative.
You don't know what w is. W is a variable. What if w is 10? I don't know what w is. But what if w is 10 and this is 10 minus 4, this is positive 6? He's happy. The fact is, I don't know. You see? It's not just a minus 4. It's got a variable. I don't know what it is. So I can't do it's negative, it's unhappy. I don't know what it is. So forget that plan. Don't do any of that plan. Do you see why I'm not doing any of that plan? Because I don't know what this is. So I'm just going back to the old rule that we've already reliably known. What do you do when you have x is vertical? What do you do with those powers? Top power minus, you just write a single x, right? Isn't this the rule you already know quite well? You write a single x, top power minus bottom, right? Isn't that the rule we've always followed when they're vertical? That's all I'm doing. I'm not doing any jumping because I don't know what this really is. It's got a variable. I don't know what it is. So I'm not doing any jumping. I'm just writing a single x, top power minus bottom power. Just like 7 minus 2, I'm writing 2w plus 7 minus w plus 4. Top power minus bottom power with a single x. That's the rule when they're vertical, right? See how I'm just following the same rule consistently? So then, what does a minus do in front of parentheses? Boom, minus w. Minus times minus is plus 4. Remember that rule, right?
So then you couldn't vertically subtract them because it would be wrong?
It would be 3 W.
Let me finish this way out.
Did I
So
curve that curve?
2w minus w,
Cancel the W's out.
1w, right? Remember, like terms. 2w's minus 1w is 1w or just w, and 7 plus 4,
11.
there it is.
I thought you would do like 2w plus 7w plus
Plus,
8, plus 4, excuse me.
it's not 7w, it's just 7 separately.
So you're not like, I'm thinking of another problem.
Okay, that 7 is not against the parenthesis. The minus is. In other words, it's not 7, it's not like this. The 7's not up against the wall.
Okay,
Make sense? The 7 is separated, and that's huge.
okay.
Only the minus is up against the wall. Yeah, only what's right up against the wall is going to distribute just a minus, not the 7. Yeah, be real clear on what's up against the wall and what's not. Does that make sense on that, Jose?
So the answer, x power w plus 11 would be the same as x power by 11w?
No.
No, huh?
Right, because w plus 11 is not the same as 11w. Because this is times, 11 times w, this is added.
Oh, okay.
On that? That makes sense? Is that good?
Well, that problem would be like everything we've been doing like yesterday with the FOIL method.
Oh yeah, we had to do this distribution thing here, yeah, which is from yesterday, you're totally right. Yeah, that minus up against the parenthesis had to hit both the w and the minus 4, changing both sides. That's right. Alex?
That's where it screwed me up, because I just subtracted vertically the way.
Yeah, and you could do that, but then you forgot the double negative thing. You forgot to say 7 minus 4, which actually adds 4. Huh?
I got the w, but I got w plus 7.
Yeah.
3.
Yeah, in fact, I think Alex's way is kind of a nice way. I mean, I wrote a lot of stuff, but watch. I bet you might like Alex's way a little bit better. Let's just go back and do that real quick. Same answer. But yeah, as long as you're careful, like you're saying, Alex, with the sign thing. Yeah. Go back here. You'll probably like this a little better. That is a little cleaner way to do it. So what have we learned again? Going back, when things are vertical, what do you do with their powers? Subtract them. You write a single x, right? A single x, and you subtract top power minus bottom, right? So let's just do that. 2w minus w, w. 1, because it's 1w. 2w minus 1w. 7 minus a minus 4.
That's what messed me up.
11.
It adds 4, huh? To be 11. Everybody see that? Because it was 2w minus 1w, and it was 7 minus a minus 4, which actually added 4 to make 11. See what happens there? You're subtracting the powers.
Yeah, that minus and minus is that.
See, I
That's
see
the
it,
trick.
but I thought we're adding, right? Wouldn't it be like 7? If it's positive 7, you have negative 4. How do you?
But you're doing, what? It's 7 minus a minus 4, like that. Why? Because we're subtracting. See this extra minus? Yeah, there's the minus from the subtract, and then there's the minus that's already on the 4. Double negative becomes add.
That makes sense.
Yeah. Everybody good with that? So just subtract the powers. We'll use the Alex method on that one. It's a little bit cleaner.
So
Oh,
you got,
okay.
you said that 2w minus the w
Yeah.
is,
Yeah, remember like from variables, like 3x minus 2x is 1x, that kind of thing. 7x minus 2x is 5x, that kind of thing. Like terms the other day. That's all I'm doing here. 2w minus 1w is 1w. Just subtract the numbers in the front. Like terms. So many rules, huh? Powers and like terms and negative powers. All right. Well, right. All right. Make it through this day. I'll give you Monday off. All right. 1/3 to the 3rd power. I wasn't gonna in the beginning. Remember?
Yeah, that's right.
Wasn't on the calendar. All right. 1/3 to the 3rd power. So, what have we learned about powers outside parentheses? Yeah, powers outside parentheses multiply powers inside parentheses, huh? Powers outside parentheses multiply powers inside parentheses. So would it be right for me to go 3 times 1 is 3, 3 times 3 is 9? Right, that's wrong. How do you know that's wrong? I'm not following this rule technically. How not? Well, why not? Didn't I just follow that rule?
You're not doing the powers, you're doing the.
Good. It's powers. Yeah, you really want to see math on 2 levels. There's base stuff and there's power stuff. And powers interact with powers, right? So you know the governor, the president, they've never taken me to lunch because I'm not a power player, right? I'm just a regular person. So I'm trying to help with the math. Just try to stick it in your mind, right? So power people usually interact with other power people, right? And us regular folk just hang out with other regular folk, right? That's how math is. Power. So that's what will keep you from this kind of mistake. Trying to keep you from that kind of mistake here. Let me go back the way it was.
I thought they only multiplied
Yes, so that was wrong when I wrote up there.
Oh.
Yeah, I do the wrong thing every now and then, just for fun. No, I'm trying to clarify, because I know students might say, yeah, so what you have to do is you have to put the invisible 1 powers, and then multiply those, exactly. So it'll be 1 to the third over 3 to the third. And then what is 1 to the third? It's 1 times 1 times 1, it's just gonna be 1, huh? And the bottom is 3 times 3 times 3, so it's gonna be 1 over 27, huh?
Could
Melissa.
you just- and since that 3 means 1/3 3 times, could you just? put
That's
it-
true.
Oh, that's.
Yeah, if you're thinking, can't we just go 1/3, 1/3, 1/3, you're totally right. And that's 1/27. That's another good way to do it. Totally, well said. Is that good on that? So powers outside parentheses multiply other powers. So powers with powers. Remember, the governor was on campus here about 3 or 4 years ago, Governor Brown. 3 years ago? Anyway, he actually came to campus to speak. The governor of our state, right, Governor Brown? He came to speak. He was outside the OAB building, Old Administration Building. I don't know, there was some kind of issue. I can't remember what it was now. And he was promoting it, and he was giving the speech. Those things always crack me. There's a small crowd gathered out there. I was just walking after class back to my office. It was like middle fall semester, spring semester, I can't remember. And there was a crowd out there, and the governor was actually on the steps, speaking at the OAB building about one of our issues. And he, so I stopped for a minute, it's the governor, and listened to what he said, but it was really actually very, very boring, and I was just kind of looking around. Maybe I'm a little twisted in my mind, but I noticed the guys with the security guys were there. They had the little things in their ears, and the suits on, and they're all looking around they always looked at the glasses and the little thing, I just thought it would be funny. I don't know, I just have a twisted mind. Because it was so boring. The governor says, blah, 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 blah. Everybody looked bored. The whole crowd looked bored. The security guys were. I thought, wouldn't it make it exciting if I just had a plastic water gun in my pocket and I just pulled it out all of a sudden? The security guys would grab me and throw me to the ground. It'd be very exciting, right? I'd lose my job and everything, but it would make a little of excitement right then. It just cracked me up, all those security guys.
The last thing they would do is throw you to the ground.
Yeah, that would be the beginning of, it just seems so boring and just funny seeing those security guys. I'd say I'm a little twisted. I just thought it would be hilarious at this point. Blah, blah, blah. All right, so 5/4 to the third. 5/4 to the third. So, all right, same kind of thing. Powers outside parentheses multiply powers. There's a power players with power players. The governor did not ask me to lunch. Powers with powers.
It's kind of like when you ask a girl out and she says, no, I'm an 8 and you're a 4, I can't date you.
Wow. That sounds like a person. That sounds like a person you don't really want to spend much time with anyway.
Sounds like
That's
something in a movie.
that's how they reckon themselves. Huh? It kind of does, doesn't it?
And she didn't say 10?
Right, for that we're saying that.
And she did, she should.
All right, 5 times 5 times 5. 125. 4 times 4 is 4. 64. Good. Use calculator for those things. Some of your calculators will do the whole thing straight. You can type it in with the parentheses and the powers and the whole thing and just hit the button. I know the natural display. Some other ones too, probably.
Oh, if you put parentheses?
Yeah. On the
How am I doing that?
with cell phones, not on the test. So, but yeah, if you have.
No, I'm doing the homework.
Oh yeah, gotcha. What do negative powers do?
They turn positive.
Well, yeah, actually, I should take it a little slower. So 5, 6. Oh, so first off, powers outside parentheses. What's that power outside parentheses going to do? Other powers. The governor takes other power players to lunch. The powers with the powers, right? So 5 to the minus 3 over 6 to the minus 3. Good so far? So the power on the outside multiplies the powers on the inside. So far, so good. Now, right, so that's just powers outside multiplied the invisible ones, right? Negative 3 times 1 is negative 3, and negative 3 times 1 is negative 3. So powers outside multiplied invisible 1 powers inside. Now, we can't stop here because we have some people unhappy at their jobs, right? These guys are unhappy, so what are they going to do? They're going to jump to the other side. And it's 6, and after they jump, they change to positive. They're happy at their new job, right? They both jump, don't they? Because they're both negative powers. And then lastly, oh yeah, we can't subtract because the bases aren't the same. Good question. I didn't think about that. Yeah, right. Yeah, if they were both 6s or both 5s, we would subtract the powers, right? But the bases are different, so we can't. That's only for same bases. Good. Yeah, I'm glad you bring that up because I forget. I just do these things all day and all night, so I don't remember the different things somebody might think who hadn't done it all the time. Yeah, so just use calculator. What's that? 216 over 125. There it is.
So the calculator will do all these for us?
A lot of them, depending on your calculator. Yeah.
Got that one you said, yeah.
Test your national display. Yeah, that will do them all. I believe it will. Now, you'll still need to learn the rules when we get the X's in there because it won't do the X's and the Y's. But for these pure number ones, absolutely. Calculators will do it.
Mine just turns it into a decimal every time.
Oh, does it? Yeah, there's no way to make it. You have like a decimal convert to fraction button? That's not the Casio natural display?
No, I don't think so.
It might be. I can check it with you at the break. See if there's a fraction to decimal conversion button. Okay, so 2/5 to the -1 power. So try that one. Powers outside parentheses, multiply powers inside parentheses. So there's invisible 1 powers, right? And the power outside, boom, boom. 2 to the -1 over 5 to the -1. So powers outside parentheses multiply powers inside parentheses, like that. And then they're unhappy.
They'll go vertical or
So when they're unhappy, they're going to jump. So again, don't think, okay, in the end it'll be don't think about that. Just think, who's jumping where? As far as whether it ends up side by side or that'll just happen naturally. Don't worry about that so much. Just say, who's unhappy? They're both unhappy. So they're both jumping. He's jumping down. He's jumping up. So it's 5 to the, and after the jump they're happy. 5 to the +1 over 2 to the +1. Like that. And that's just 5 over 2. We don't, 5 to the 1 is just 5. And 2 to the 1 is just 2. Huh. It's just 5/2.
Maybe because I know, so why don't I just turn the 1 positive and then I just both it so I know it's 5.
You're right. In the end, the negative power is just going to flip the fraction because it's going to make them both negative. They're both going to jump. So just flip the fraction, and then the 1 power doesn't change any numbers. Exactly.
And we'll stop right there.
Yep.
We won't continue anymore.
No, it's okay to have the top of the fraction bigger. That's okay. Let's leave it like that. That's right. All right. So, E, we're doing the letters now. E over F to the 7th. E over F to the 7th. So, what do powers outside parentheses do? Multiply the invisible 1 powers on the inside. Huh? Boom and boom. So you get E to the 7th over F to the 7th. And that's it. Because the bases are not the same, we can't. Good question, good question. Yeah, if these were both E's or both F's, then we would subtract the powers, huh? Yeah, so all those rules about when they're sideways we add or when they're vertical we subtract, that's only for matching bases. Same bases that we can do the add or subtract rules. Yeah.
that's the answer right there.
That's just it right there. Yeah, can't go any further. Good. Okay, so 7u over v to the 7th. Okay, what's the rule again with powers outside parentheses? Yeah, so go ahead and do that. Powers outside parentheses. Multiply. Powers inside parentheses.
It's too large a number to factor out.
Right. Okay, so here's the mistake I see a lot. Tell me what's wrong with this. I see people all the time go, oh yeah, I know. Right, because there's a 1 power and a 1 power. The 7 goes boom, boom. There it is, I got it. That's wrong, huh? What's missing?
7.
Yeah, he also has a 1 power. Yeah, don't forget, even the number has a invisible 1 power, and the powers multiply there too. Yeah, and then you're good. That's it right there. That's the correct answer now. Does that make sense? So the power outside parentheses multiplies all the powers. And everybody has a 1 power, invisible 1 power. Good.
So the answer would be 7,
Yeah.
power 7, u
That's
7.
what I asked him.
Over v to the 7th?
Yeah.
Yeah, that whole thing is the answer.
Yeah.
Because there's a 1
Where's there 1?
on top of the 7.
Yes, right here.
Invisible 1.
Yep. Yep, there's a visible 1 powers on everything.
Okay.
And that 7 power outside multiplies all those invisible 1s. That's it. Everybody has the invisible 1 power.
So it's 123,000.
So what it is? Oh, give me the number again. I mean, I could do it in my head, but I hate to show off. Go ahead, Alex.
823,543.
543, okay. That's what I thought. All right, there we go. U to the 7th over, yeah. So use your calculator. You guys know how to do the power button on your calculator?
Yeah.
7, you know, the X to the Y or the up arrow, depending on your calculator. 7.
So in reality, that's the answer.
Yeah, this is what they really want.
Okay, not the
Yeah,
7.
well, the 7 to the 7th does become this. That's how we got that.
Right, that's what I've got, and I was just a little confused.
Gotcha. Yeah, they don't want me to stop at the 7 to the 7th. They want me to get the
Continue. Okay.
big. Some of the other ones, they were having to stop. But this one does say, as you guys pointed out, simplify now, so.
Now, in mathematics, if I'm showing an answer and I put a comma like you did to break the,
Uh-huh.
is that changing the answer at all? Because I know when we write out a number in everyday use, we always put commas in to know which
Yeah.
one's millions, which one's hundreds,
Yeah.
thousands and hundreds. But does that change the answer at all? Like, if I wouldn't write a comma in for math Excel, would I?
Oh, you can. Well, I think you can. Yeah, I think it takes it. Yeah. No, this is fine. Yeah, that's fine. Common use is fine. Yeah, just common use on that is good. All right. All right. So here, let's finish this one. We'll take our break. We're about at break time here. All right, let's try that one. Powers outside parentheses. Powers outside parentheses multiply powers inside parentheses. So boom, boom, right? Powers outside multiply powers inside. So that minus 2 is going to multiply minus 7 and multiply minus 8. So negative times negative? Positive 14. Positive or just regular. And positive 16 or just regular. And that's it. All right, we're done right there. Why? Because everybody's happy now. Powers are positive, they're happy. And why can't I add the four? They're side by side. Why can't I add them?
Different bases.
Different bases. If they were both A or both C, I would add them to be whatever that is. But if they're different, you just leave them. All right, that was a lot of rules in 2 straight hours. Let's take a break, huh? 10-minute break.